Okay, so let's do example 1 here using your hand. So 60-degree finger. Your 60-degree finger is your pointer finger, so put your pointer down. Okay, so you got your left hand up in the air, you have your pointer finger down. So sine. Sine is the square root of everything to the left. We'll count how many fingers you have to your left. You have 1, 2, 3 fingers, that's why it's the square root of 3 over 2. There's your answer for sine. To find cosine, keep that finger down. Cosine is the square root of everything to the right over 2. Well, how many fingers do you have to your right? 1. So it's a square root of 1 over 2, which is 1/2. Tangent. Tangent is the square root of the left over the square root of the right. Well, how many fingers do you have to the left? 1, 2, 3. So it's square root of 3 over, how many fingers do you have to your right? 1. So it's a square root of 3 over square root of 1. The square root of 1 is just 1. So the answer is a square root of 3. So there's sine, cosine, and tangent. To find cosecant, just find the reciprocal. So if sine is root 3 over 2, all you do is flip it. So cosecant is 2 over root 3. But remember, you can't have roots in the bottom. So you multiply both the top and the bottom by root 3 to rationalize it. So it's actually 2 root 3 over 3. Cosine of theta. The reciprocal of that would be secant. So to find secant, I just flip it. So that's 2 over 1, which is 2. And tangent. Tangent was root 3 over root 1. So if you flip it, you end up getting 1 over root 3. But remember, you can't have a root in the bottom, so let's rationalize it. So I multiply by root 3 on both the top and the bottom, so you get root 3 over 3. And there are all 6 of them done. What math did you do? All right. That's the math, which you can even do in your head. Remember, same square roots cancel out, just giving you the number underneath. So basically, you didn't even do any math there. Okay? We got all 6 of those without doing any math.
Well, Homer.
So now let's try 30. So 30-degree finger is your ring finger. So sine is square root of everything to the left over 2, which is 1 finger. So that's 1 over 2, because it's square root of 1 over 2, which is 1/2. Cosine is everything to the right, square root of the right over 2, so 1, 2, 3 fingers to the right, so root 3 over 2. Tangent is the square root of the left, which is 1, over the square root of the right, which is 3, so 1 over square root of 1 over square root of 3. Remember, rationalize the bottom. That's root 3 over root 3, right? This, because you can't have that in the bottom, so it's root 3 over 3. So to find the cosecant, you just flip it. So that's 2. To find the cosecant, you flip that, or secant, you flip cosine. So that's 2 over root 3. That will, when you rationalize the root 3 over 3, so that's 2 root 3 over 3. And to find cotangent, you flip that, so that would be root 3 over 1, which is just root 3. 45 degrees, that's your middle finger, so put the middle finger down. So when you put your middle finger down, sine is square root of the left over 2. Well, how many fingers are to the left? 2. So it's root 2 over 2. Okay, get some filling these all in first. Here you go. So that's root 2 over 2. Cosine is a square root of right over 2. Square root of the right, there's 2. So that's also root 2 over 2. Tangent is the square root of the left over the square root of the right. Well, that means that's just root 2 over root 2. Well, the same thing on both the top and the bottom means that's going to cancel out and give you 1. So I flip this. So I flip that to get 2 over root 2, which when I rationalize the denominator, root 2 on the top and the bottom, so you get 2 root 2 over 2. The 2's cancel out to give you root 2. They're exactly the same. Don't do the work again. They're exactly the same, so you're going to get root 2. And when you flip 1, you get 1.
Time to go home now, little Yummy.
So we need to go over what a reference angle is, and the reason why you need to go over what a reference angle is very important. Like I said, the hand only works, the Mars-Log left-hand rule only works if it's in between 0 and 90. But for example, what if I said find 120 degrees, find 150 degrees? You can still use your hand. You can use your hand by using what we call reference angles to figure out what that degree would be on your hand that could get it to work. So the reference angle is an acute angle to the terminal side.
Yummy.
it must be 0, 30, 45, 60, or 90 in order to use your hand. So finding a reference angle in quad 1, it is what it is. There is no reference angles in quad 1. It is what it is. Whatever I give you is what it is. So quad 2, however, how do you do that? Well, here's how you do that. If I gave it to you in degrees, this line here is 180 degrees because it's a straight line. So to find out what that is, you just do 180 minus theta. That'll give it to you in degrees, or you do pi minus 180, because that'll tell you what's left over, and you can figure it out. In quad 3, right, this is a straight line, so that's 180. So basically now you're doing 180, and you're adding whatever that angle is to it to get your answer. And that'll tell you what it is. So to figure out what that is since you know it's bigger, since that should be bigger than 180, just take this angle and take 180 away from it, and that'll tell you what's left over, or take a pi away from that. And in quad 4, the whole circle is 360. So just do 360 and take away that little part, and that'll tell you what's left. Okay? So just use logic here, then you can figure out what that angle measure is for each of these. 180 minus that, whatever that angle was, minus 180, because think about it, you want to figure out what that angle is inside of there. So you got to remember straight lines, circle is 360 degrees, so 360 minus that theta there.
Chunky.
So now we're just going to find some reference angles. 315 degrees. Well, this is 0, that's 90. That's 180, that's 270. Remember, it's 90 each time around. So this is 270, that means 315 has to be in this quadrant. So, how could I find out what this angle is? Well, if the whole way around is 360, I just do 360 minus 315, so that's a 45 degree angle in there. Drew this one, negative 240. So, this is 90, this is 180, this is 270. So that's too far, so this should be in this quadrant right here. So to figure out what that answer is, that's negative 240. So if it's 180 to here, 240 minus 180 would be 60 to make that work right in there. So that's 60 degree angle. 5 pi over 6, well, 6 pi over 6 would be 1 whole the whole way across. Okay, radians are actually easier to solve these. I'll show you how easy these are when they have them written in radians. Very simple trick. When they have them written in radians, I can already tell you what finger you put down. Whatever the bottom is. It's 5 pi over 6, so the reference angle is pi over 6. If I said 3 pi over 4, the reference angle is pi over 4. It's whatever the bottom is. It's pi over 4. If I said 2 pi over 3, the reference angle is pi over 3. Okay? These are easier to solve, I'm telling you. It's the degree ones that you have to actually think a little more to find the reference angles for. Radians are a breeze, because you do pi minus that if you don't believe me. Pi over 6. 4 is in radians, not degrees. So remember, pi is 3.14. So 4 would be a little bigger than that. So 4 minus pi would be what that is. So use the reference angle to find the exact values of sine, cosine, and tangent of the following. Like I told you before, okay, pi over 6. Why pi over 6? Because whatever this is on the bottom, that's your reference angle. Radians are easy to find the reference angles. So 5 pi over 6 is going to be pi over 6 as the reference angle. So we'll get to that when we come back.